Hello guys, today we'll be solving this question which is titled number of provinces. Uh, Given an undirected graph with V vertices, we say two vertices U and V belong to a single province if there is a path from U to V or V to U. Your task is to find the number of provinces. Okay. Note a province is a group of directly or indirectly connected cities and no other cities outside the group. So basically they ask us to find the number of provinces and the number of connected components. Number of connected components is two here. One and three are connected and these together combine to form one component and this isolated two is a second component. And for this, we just have one component, and let's say we would have had another isolated component of 5, which is connected to 6. So we'll have three of those, right? 1, 3, 2, and then 5, 6 here. So basically, we'll have to find the number of components which are separated, right? Which are not connected to each other. So that is what that is what is we're supposed to find. And what we'll do is the approach is very simple. We'll do any kind of traversal, be it BFS or DFS. If we start by one particular node, let's say we are doing a DFS traversal, we'll start from one. It will mark this one as visited, and then it will mark three also as visited, right? So when we do a DFS traversal of three, we won't increment the count. So for every component, we'll increment the count once. Let's say for this component, we start with one, it touches three, and then we count only one for these both nodes. And then for two, when it comes, we count like increment the count by one. Similarly for this, since both of them are connected, we'll just count this as one component because when we'll start with two or one either of those, it will of course make this also visited, right? Because these are connected. So if we do a BFS from two, it will of course go to one next, and then one will be marked visited. First two, then one. So this is how it works. Uh, but the catch, the difference this question has is in the fact the way this adjacency matrix is given. We're not given with a list. We can either do with this matrix itself, or we can convert this to a list. We convert it to a list for simplicity. N is equal to join adjacent matrix for size. Fine. Now we'll make an adjacency list. Vector and adjacency list size v. Mm. This is just initializing the adjacency list with converting from the adjacency matrix to adjacency list. And this is very easy. And we just have to take care of a case wherein if adjacency I and j is equal to 1, means there exists an edge between these I and j, and I is not equal to j. Why so? Because of course 5 will be connected to 5, right? Because both of them are same. So what we'll do is we'll adjacency list push. Yep, since the graph is undirected, we'll have to push for I and j both, right? This graph is undirected. So from 1 to 3, we don't have an edge that is signifying that we just can go from 1 to 3. We can either go from 1 to 3 or from 3 to 1. So we'll have to mark 1 and 3 and 3 and 1. 1 as in the adjacency list of 1, we should have 3, and in the adjacency list of 3, we should have 1. So push j here, and similarly, adjacency list of j, we push I. Now we have the good old adjacency list, and we can do the DFS traversal, which we have already done in the previous video. What we'll do is we'll make a bool visited array. We'll call this DFS for what? We'll call this for every node that is unvisited, right? So if visited of I is not equal, if not visited of I, we'll call DFS. And once we call DFS, we'll have to increment the count by one, right, for each island. So int number of islands is equal to 0. We'll call DFS. What will pass? We'll pass I as a node. We'll pass visited array. We'll pass the adjacency list, and we'll increment count by one for every subsequent, every corresponding DFS traversal value, and we'll return number of islands. Now all we have to do is write a code for performing the DFS traversal, which I declare as a private number, void DFS, DFS, right? End node, bool visited, and vector and adjacency list. Fine. We'll mark visited of the initial node as true, and for every subsequent neighbor of it, we'll call this repeatedly. Mm, DFS of what? DFS of IT visited and adjacency list. Do we have to return anything? No, we don't. And I guess we'll be good to go. Yep. Run this and see. I have a couple of errors as customary. Yeah, we do. Begin was not declared in the scope, so are we declaring the vector differently? Vector and adjacency list. Sounds good to me. Okay, fine for that. Yeah, yeah. Not the node, right? Adjacency list of the node. Are we fine? We have some other errors? No, we do not. Okay, left it. Oh yeah, it is not count. It is number of islands that we have declared. Now, take a look. Yep. I guess you would have understood the approach. Thank you. Until next time. Bye.